Hello, this is Andre again. Today I'm going to show you the process of building the MicroPET Release 2, so stay tuned. The MicroPET 2 is a rework board from the MicroPET Release 1 with a number of improvements. So it has double the amount of RAM with these two RAM chips. So it has 1 megabyte of RAM, and half of the RAM can even be used at full speed because it's not used at the same time by the video reads. It adds a specific SPI channels for an RTC real-time clock chip here, for USB chip, for an Ethernet board that's going to be a breakout on top of that, and SD card. All in addition to the SPI Flash ROM that the machine boots from. The IEEE 488 connectors have been replaced. Those are originally were such connectors here. They have been replaced by Commodore card edge connectors. And it also adds a card edge connector for a tape port. But there is an option to have pin headers here to add an adapter to again have the original IEEE 488 connectors, but they, well, difficult to get. It replaces also the basically unobtainable original IEEE 488 driver chips with these two 74 LS 641-1 plus pull-up, pull-down resistor networks. So those are still available today. Also, it includes the VGA output right on the board and adds a reset switch and proper power and audio jacks. Unfortunately, some more chips had to be put into SMD to restrict the board size to that what I can build. When I got the board from the factory, I had all the SMD parts, chips and capacitors already put on the board during the manufacturing process. So you may decide to do that yourself if you're good enough in SMD soldering, but I was kind of lazy. The first step then was to add the 3.3 volt power regulator to see if the 3.3 volt generation of the CPLD was working. So I gradually increased the supply voltage, the bench power supply, and looked at that the ratings of the CPLD chips were not exceeded, so that was good. Then I added the power LED, very great improvement. And the next step then was adding a JTAG connector for the CPLD, so I was sure that I was actually able to program the CPLD. You may note that this is a different connector from release 1, as I have built a flat ribbon cable to the CPLD programmer output connector, as you will see in the later picture. This makes it much easier to connect it compared to the single wire connections still seen on that picture here. The next step already was to establish stable video output, which works even without the CPU. It's just showing random garbage from the memory. And that also included a reset circuit, as a video needs to be reset after reprogramming the CPLD. Then comes the CPU and the boot ROM. And this really took a long time debugging. And I finally found out that the 74 HCT 245 level converter I put into the CPU clock line between the CPLD and the CPU was actually messing up the timing too much. So I had to revert to the circuit from release 1 board with a simple pull-up resistor and some special programming in the CPLD. And in fact, the result is that the boot screen was now showing. After that, it went really quickly, adding the VIA versatile interface adapter and PIA peripheral interface adapter chips, the keyboard interface to get from the boot screen menu to the actual PET, and then the IEEE 488 drivers and audio circuit. So what I noted was that there are actually two missing lines on the board. One is the clock signal for the I/O chips, which is a separate clock signal generated from the CPLD, and then there's a select signal for the real-time clock chip, which is not yet there here. So there will be some additional soldering, but this will be fixed in the released board schematics. This happened because there was a naming issue between multiple sheets in the schematics, and this is one of the reasons I actually like single sheet schematics. But anyway, it will be fixed. So, and here we are with the MicroPET Release 2 with the classic PET functionality. So what will be next is adding the extra SPI peripherals. Some SPI chips have already been put on the board, but there's additional, there's a USB connector, there needs to be the connectors for the Ethernet breakout board, and so on, some capacitors, crystal oscillators, and stuff like that. So this will be the next step, and then after that, I will have to see how I can fit that into the case that I have here, using some designing and using some 3D printed part. So that's it for today. You can now watch me playing one of my favorite PET games if you like. Otherwise, thanks for watching and see you next time.
Oh, the joy of playing those old games again. Ay, ay, ay. Oh, and then you wonder why on our school pet the spacebar was broken all the time.